Yeah, good evening.
Yeah, good evening, everyone. So we'll be starting the session formally. First, a very big thank you for joining, for being on board with us. I hope I'm audible. Team, if you can just let me know if I'm audible.
We can hear you. Thanks.
So, very good evening, ladies and gentlemen, faculty colleagues, esteemed panelists, students, industry partners who have joined us. Now, I think one common thing which we all will agree on is that technology, innovation, investments, collaboration. These are some of the key words or the defining words for Viksit Bharat coming up in 2047. And taking cue from this, and Mumbai is proud to host a very brainstorming and deliberated session today on a very aggressively talked about topic in the industry parlance, that is clean tech driven supply chains. It's a very topical and a contemporary topic. And with this in the mindset, the event got designed and curated under the leadership of Honorable Director IIM Mumbai. For successfully conducting this, arranged some of the eminent speakers from the industry from across the domain, particularly consulting, clean tech, considering the topic is on clean tech, investments, very critical role to play in, and finally on sustainability. And here we like to understand, are we able to walk the talk which is happening in the industrial parlance today, in the regulatory parlance today? So with this perspective setting, I'll invite Professor Seema Unikrishnan, Senior Most Professor, IIM Mumbai, to kindly welcome the gathering today.
Thank you, Professor Hema. Good evening, dear esteemed panelists. Good evening to all our faculty colleagues, our defense students, and our postgraduate and doctoral students. This evening is special because we are having the workshop on clean tech and clean tech driven supply chain for Viksit Bharat. So Viksit Bharat is the government's action plan to turn India into a developed nation by 2047. That is exactly 100 years after gaining independence from the British rule. So today's workshop is on the theme clean tech driven supply chain management for Viksit Bharat. And this falls under the broad thematic area of transport infrastructure and logistics. So under Viksit Bharat, they have a whole lot of focused thematic areas where this is one of the important thematic areas. And under this particular thematic area, we have sub-themes. So some of the sub-themes are on building world-class infrastructure, on decarbonizing transport and renewable energy, on green economy, and on India as a global logistics hub. So these are all sub-themes under that. And we will realize that the supply chains across the world are slowly moving towards achieving net zero emissions and net zero transition. You see that across the world, many countries have introduced policies for also transitioning to electric vehicles, for moving towards green hydrogen. We have even in the supply chains automated warehouses which have less emission intensity. We have solar and wind energy powered warehouses. So we have a whole lot of clean tech implemented upstream and downstream in the supply chain. So, for example, take the example of electric vehicles. Today, we have policies in place for electric vehicles, but you will see that this again depends on the grid emissions of the country, which means a country which is highly energy intensive, the grid emissions are much higher. Then, for an electric vehicle to be very efficient, we have to actually move towards a renewable energy efficiency, which means all our power plants slowly move towards renewable energy. Another important aspect is the life cycle, assessment of all the products, which will tell us upstream and downstream of the product what will be the kind of impact it has on supply chains. So you will see that just as many countries across the world have introduced, policy for electric vehicles, we have countries which have also implemented policies on green hydrogen. India has also been doing pretty well in this. In 2022, we had on green hydrogen, which was formulated. And under this, you will see that we are of becoming quite, self-sufficient in the production of green hydrogen. So India aims for an annual production of 5 million tons of green hydrogen by 2030. And this will really help us in many ways. Another important thing that is happening in our country is with BRSR being made mandatory by SEBI. you will see that many corporates, it has been made mandatory that carbon footprinting has to be done. Scope 1 and Scope 2, that is direct emissions Scope 1, and Scope 2, that is purchased electricity, is mandatory. And Scope 3, which covers also upstream, emissions from your suppliers and downstream emissions from your suppliers, that is at present voluntary. But in the years to come, you will see that slowly your suppliers' emissions will also be a part of your Scope 3, and it might become mandatory in the years to come. So it's very important that all the suppliers, vendors, everybody move towards green tech and clean tech to transition towards net zero. So this is going to become like the necessity of the hour. And you will see that across the world, so many changes are happening. New technologies are coming into play to take care of this requirement of moving towards net zero. So clean technology supply chains will also need to adapt to the requirements of moving the raw materials and components needed for example, electric and hydrogen vehicles, such as proper temperature control, as well as compliance with dangerous goods regulations, especially if you're going to start using green hydrogen for transportation purposes, which are being planned in future. We also need to develop supply chains with circular economy perspectives, which means set up robust recycling industry with new recycling technologies to reduce the demand of raw materials. So these are some of the things that we'll be looking into in today's workshop. So I'll now invite Professor Hema Diwan, who will be moderating the whole session. So thank you and welcome again to all of you.
Yeah, thank you, Professor Simon Krishnan, Madam.
So we'll start with the actual panel discussion now.
So, team, how are we going to go about? So, a discussion would be moderated by myself, Hema Devan, one of the faculty members. Since the topic is on clean tech and particularly clean tech driven supply chains, and we know that the supply chains for sure globally are changing now. It's not only in the nomenclature, but in the design itself. We started with some global supply chains. We saw an era and still seeing complex supply chains coming in making, with sustainability coming in, the supply chain era came in. Today, post-COVID, we are talking also about resilient supply chain. And in current context, it's about the clean supply chains which are being talked about. So very relevant for the industry and academia to come together and deliberate and brainstorm how this change and how a learning curve would come around for this kind of change, which Viksit Bharat is wanting to have. It's also now important to understand and address that the industry leaders now are being increasingly talked about the efficiency of their supply chains or their operations or their productions, etc. And this efficiency is not in terms of time or cost or quality or delivery or materials alone. It's also on some very different kind of parameter which is being asked on, as in what is the carbon footprint of a supply chain, for example, supply chain logistic related function. What are the environmental footprints coming in? So GHG or sustainability related efficiency pointers are also coming into the industry today. So it's a top-down approach which is being seen from the leaders asking to understand what are the impacts of the supply chain or the value chain coming in. And here starts the complexity that is on configuring cleaner options so that the environmental footprints are also on a lower side. And its integration, it's not about technology, it's about its integration into the supply chain functions as well. So today's scenario, we'd like to talk about more on what is the business as usual scenario coming in, how we are challenging the BAU today, in what context this is coming in, and what kind of requirements are there to get the learning curve right. So with this thing in our minds, with this kind of takeaways which we are looking forward from the workshop, I open the floor for discussion coming in from eminent panelists. So we'll be joined by Honorable Director IIM Mumbai, formerly NITI, Professor Manoj Kumar Tiwari. And we are also having on board with us Mr. Rajan Varshney, Deputy General Manager, NTPC. Also, Mr. Tejas Devras. Tejas, I'll take the liberty considering he is the alum, and we are proud of that. Vice President Investments, NIIF. So thank you for your confidence in joining this workshop today. And last but not the least, Mr. Mithilesh. He's our consulting partner today, Vice Lead and Associate Director, Accenture. We'd like to understand the end-to-end kind of solutions which will be coming in for making this clean tech driven supply chain a reality integrating sustainability in various functions across. So with this, I'll open the floor while any one of you can come in. But I would like to just start off, considering it's clean tech, I'll start the baton with Mr. Rajan Vashne, Deputy General Manager, NTPC. And I would like, before I ask him to come up with his thought process, I would like to introduce Mr. Vashne. So Mr. Rajan Vashne, he's Deputy General Manager, NTPC, largest power company, which is diversifying into many other fields, and sustainability happens to be one of them. Mr. Vashne is an MTech from IIT Delhi and BE and MBA again. He holds n number of certifications, and one of the one which struck my attention were Harvard Management Mentor. He is. So we are looking forward to that kind of mentorship from you, sir. Then he also holds certifications in carbon markets and energy markets, which is a very happening trend today, to come up with that kind of, to break that ice on financial part. How to make investments happen? Is that actually happening, or it's just, we are just trying to gear up for that kind of thing to happen? He has over 35 years of experience in energy sector. He has been spearheading n number of notifications at national level, where he oversaw permitted fuel in Indian Motor Vehicle Act and safety standards for. Then his interest areas includes renewable energy technologies, RE systems, something to talk about concentrated solar power, etc. Carbon dioxide capture and utilization, hydrogen economy, which is coming in a big way, which is yet to be scaled up. Still at many levels, we can say it's a pilot happening. Then, sir is also a governing council member and certified trainer for hydrogen and RE space from Skill Council for Green Jobs, which is an initiative of Government of India promoted by Ministry of New and Renewable Energy. Thank you so much, Mr. Vashne, for joining us today. So the ball is yours now. Please let us know.
Good evening, everyone, and thank you for inviting me for this Clean Tech Summit. The topic is very close to my heart, and I'm very passionate about it. And the things which are required now, you have spoken about mobility, but if it is electric mobility, and like Madam also pointed out, grid is 90% coal based, then what are we saving? Really, pollution is not lesser. Rather, we are dependent on one or two countries for battery chemicals and battery cadmium and lithium, instead of importing those things like petrol and diesel from 24 countries or gas. So it is not cutting down our imports, it is not cutting down our pollution also. So better is either we use solar cars, solar buses, solar vehicles. And if you see, most of the cars run for 10 to 15 kilometers in cities. And then in the office, it remains just stand still in the office. And then in the evening, again, it is run. So during the day, it can be charged easily and without so much grid electricity to be used, unless it is very much required. But we have other solutions also, like hydrogen cars or HCNG buses, HCNG trucks. Similarly, when we have to just run vehicles, we can do it in IC engines. And in September 2020, I spearheaded one notification of HCNG as a permitted fuel under Indian Motor Vehicle Act. And it was 585E and was notified on 25th September 20. And after that, from 1st October 2020, 50 HCNG buses were run from under DTC from Rajghat bus depot. And the parameters, the test results were really mind-boggling. 70% reduction in hydrocarbons, HC. 23% reduction in NOx as compared to CNG. SPM nearly zero, because when you have put in some hydrogen, your this thing output becomes steam, and RSPM has no way to escape out. So such innovative steps should be taken. Now, what is happening after those 50 buses ran for 66 months? Nobody is willing to put that 1 crore bill for a autocatalytic reformer, which sits over your CNG tank in the CNG station and directly produces HCNG. Why to first produce hydrogen and spend 50 or 60 units of electricity and waste so much water when we can simply do it through biomethane and just convert only part of CNG, don't purify it, just make it HCNG. HCNG is a standard name for 5% by weight hydrogen in CNG or 18% by volume. So this was done by IOC reformer, which they have patented also. It's set over that tank and directly delivered and without any expenses on the bus side. Same bus, only minor tuning, just like you change your gas stove from LPG cylinder to your piped natural gas. So only minor tuning and only this expense, this 1 crore expense could have run 5,000 buses because the CNG pressure outside is same pump, same everything, same compressor. 250 bar pressure is there for bus filling. So, if our aim is to control pollution, to control GHG emission, eliminate waste or reduce waste, so this can be very easily done. And import also reduction, energy security also is. So this is one example. Other example is, the best part or worst part, whatever you say, it is very cost effective. Even it increases the efficiency of the bus by 4% because hydrogen burns in a better manner and it also helps the natural gas or methane also, biomethane also to run, I mean, burn better, better combustion. And that is why your HC and CO and other things get reduced. And moreover, you can earn carbon credits also. But what everybody is doing, FAME scheme is there, same 50 lakh bus, instead of running that, we are running EVs at 1 crore or 1.5 crore or whatever. That subsidy is coming from taxpayers and more buses are running. And same grid, same everything, supplying that electricity. So these innovative steps should be taken, and then if we can do hydrogen from waste, I've recently my book has been released that is uh, combating climate change with hydrogen economy. So this is by Springers, and it is indexed on Scopus and also Elsevier. So in this, biomass to hydrogen is my topic there. Although waste is also equally, once it is wasted, that means I have to realize worth out of it. So I can convert waste to methanol or DME or other things. It can be a direct replacement of fuel and imports get cut. Or I can go for hydrogen also. And through this route, if I have a waste available free through biological route, which is called microbial electrochemical cell, I can have very costly byproducts like disodium terephthalate, ethylene glycol. Disodium terephthalate sells at 65,000 rupees per kg. My hydrogen can be nearly free. So similarly, if I do gasification of waste, I don't need segregation. I just gasify the waste, produce syngas out of it. Syngas is the basic chemical, basic building block for anything which I require from petroleum. Now I don't need to drill petroleum. I don't need to cut down my forests. I don't need to import anything. I have tons of waste, millions of tons of waste every year. And I can just make hydrogen out of it. By PSA, we can segregate that syngas. And it will cost around 80 to 100 rupees per kg. The other method is if we segregate wet waste, we convert it to biomethane, then biomethane to hydrogen. Again, it is a very simple process. And in that, there are better processes coming up. Today, if I do biomethane to hydrogen, it takes me around 6 kg of biomethane to make 1 kg of hydrogen. Out of this 3 kg goes into just heating to reach the temperature of that steam methane reforming. But now we have solar methane reforming through concentrated solar power. Through concentrated solar power, we have huge high DNI areas lying vacant where we can produce 24/7 renewable power at much cheaper rate than presently we are producing from coal. And that power can be used for producing hydrogen either through electrolysis or that high temperature, even up to, we can realize temperature up to 3000 degree. Already an NREL lab has done it for last 10 years. It is continuously running at 3000 degree temperature centigrade. So water gets split at 2400 degree or something like that. Otherwise, we have photocatalytic splitting of water. We can do it through the CSP and CST part, and we can get hydrogen within 80 rupees per kg. So when my hydrogen is cheap, who will go for biomass, coal or gas or anything for heat or power? But the thing is, these things need to be encouraged. First, people are should be aware and then follow these these innovative steps. What I have done is I have just made business cases out of it. I am producing some high value added product and my hydrogen is getting cheaper. Similarly, I can do methane pyrolysis and it is like no carbon is emitted. It is like solid carbon is coming and the hydrogen. It is like C and H, C and H2. So that solid carbon can be in the form of graphene, which is 5000 rupees per kg, fullerene, which is 10,000 rupees per kg, or graphene oxide, or graphite, or carbon black. All these are replacement of my petroleum or fossil carbon. So all these things earn me a lot of carbon credits. If I incorporate these, my hydrogen can be really free. So India has a lot of potential, a lot of innovations are happening at the intersection of various chemistry, biology, and other things, and specific branches, nanotechnology, and everything is getting used here. So there is a lot of scope, and I feel our IIM Mumbai fellows should work on it, and let us discuss further. Thank you.
Okay, thank you, Mr. Vashnik. So having said that, while technology development is required, technological benchmarking is for sure required with respect to various feedstocks which are available and see which could be one of the most potent ones on production of various clean tech related fuels, alternate fuels, which we are talking about. But it's also about, so it's not about productions alone. It's not about manufacturing alone. It's about some integrated issues which are coming from supply chain side. So the supply chain issues like physical infrastructure, for example, for transmission of energy, for distribution of energy, or the integration with the conventional energy systems, or the price parity, scheduling, planning, entire supply and demand thing, demand projections, temporal and spatial uncertainties which are making the way. For example, if I want to distribute hydrogen as a fuel, now these are the hiccups which are coming up, and certainly we need to deliberate on that. While technology is important, the integration with the supply chain issues are equally important, which needs to be addressed. So if at all anybody from our panelists, maybe Tejas or Mithilesh, can just speak about how this kind of thing is unfolding, what are the asks which are coming from the clients, how the investment space is changing, considering that reliability, accessibility, diffusion, commercialization is required right now if technology development happens. So beyond the production parlance, how are we going to navigate this territory? Yeah. So
how would you advise? Tejas would like to go ahead, or I have some pages to respond to this. So I'm happy to do that. Please let me know.
Please
Yeah.
go ahead, Mithilesh.
Mr.
I can go
Mithilesh?
after you. Thanks.
Yeah, thanks, Tejas. Thanks. Yes,
Okay, all right. So can someone from the participant confirm if they can see my screen?
we can.
We can.
And I was listening to the previous discussion and we'll try and build on that. And I think Professor Seema, when you teed off the topic, you did talk about there are 4 key tenets within how we as a country should look at.
Mr. Mithil,
Um,
pause you for a minute.
Sure.
Let me introduce you while we all know you. We would like to introduce you for the audience we have. So Mr. Mithilesh Kumar leads the chemical and natural resources industry groups as a part of Essential Technology India, with overall 16 plus years of experience spanning industrial equipments, refineries, steel, chemicals, pharmaceuticals, mining, pulp and paper industries. His focus is also on digital technology enabled business transformation. He specializes in various domains, particularly ESG and sustainability, data analytics led business excellence, operational and commercial excellence, and RT. At Accenture, he's also playing the role of industry sustainability lead as a part of technology centers in India. Having worked with clients in multiple geographies, Mithilesh brings the global perspectives on board today for us in technology-led reinvention for the various clients, for the various projects he handles. He's a management graduate from Symbiosis. So while I can speak a lot, but Mithilesh, this is, in short, I would like to keep it. Please come up with your thought process. Yes.
Thank you for the graceful introduction. And as you saw, right, the moment there was a nudge, the consultant was ready with his set of PowerPoint slides. Although we advocate PowerPoint free consulting these days, but I could not stop myself from bringing some pages. I hope that's fine for the audiences. So, all right, picking some of the cues from Professor Seema ma'am when she said that decarbonizing the supply chain is one of the key considerations. And if you really talk about India, for example, I mean, let's take a perspective into intra-India, within India perspective, and then what role does India have when it comes to India making a difference in global supply chain, right? So I'll talk about the role India has. If you really look at geography of India, and pardon my geography, you will pretty much say that from west to east, you're talking about close to 2,000 kilometers, right? And from north to south, you are talking about close to 4,000 kilometers. And if you mentally map a quadrangle around this, and even in our MBA days, by the way, Mr. Devras and I graduated the same year. It just that happened to be coming from different institutes, right? So I still remember how we used to debate and discuss the construct which India had till 1960s and industrialization to have the natural resources scattered in the eastern part of country and to give some advantage to the western part, which was less resource focused, to have the manufacturing setup and incentivize, right? Now, it has some implications for us as a country, right? And I was also reading, I think one of your peers, I am Shillong, has recently started a center of excellence to really focus on imbibing more efficiency, resilience, especially decarbonized ways of thinking on the supply chain side. And it has a very strategic meaning for India. If you really look at the growth, right? I mean, US pretty much stagnant. Europe is bleeding with negative growth. If we really talk about consumer-driven growth and the growth which is about to, stay, you are looking at countries like China for sure, even now, and you are also looking at countries like India. And to the east of India, you are looking at countries like, say, Vietnam, as it comes to really, having those mega factories. China is, of course, number one there. So my perspective is, if you think of India as a country, there has to be a lot of focus on how is it that we create that infrastructure, those many infrastructures. I think Mr. Karan talked about how is it that, Mr. Vashni talked about how is it that we should think of some of the most cost-effective ways of producing hydrogen, which gives you, economy of scale, right? I'm fully onboarded onto, some of his ideas. But I think the eastern part of India has to be developed on 3 accounts. One is on the infra side, which includes your port handling capacity. And I think some of the policies which government of India has taken in the last 5 to 7 years, puts us in good position wherein we get to exchange and share the port capacity, especially with, Bangladesh, some of the port capacities, which allows us access to Southeast Asia markets, right? So I think politics and the sense of collaboration also makes sense, right? Which allows some of the biggies. Some of you would have seen how Adani plans to have its green energy venture. Some of the India-based companies are also trying to foray into that, right? So I think the starting point is having a very strong, very decisive commitment on, yes, we will do the development and there will be ports, processing centers, especially when you talk about food-based exports, to have that kind of facility. But let me come to the core topic and be very quick about it on decarbonizing the whole supply chain, right? To the left side, there are some key modes of transformation, transportation, and their triggers, right? And on the right, you see there are some challenges which at least I see having worked in this domain, especially in the last 3.5 years with our clients. So one of the biggest questions our clients are asking in this domain is, what do we do with our existing fleet? Some of you would have seen with Mr. Gadkari becoming very focused on phasing out gasoline-based vehicles. What do we do with the existing fleet? So comes the topic of, should we dispose them? Should we repurpose them? And therefore it necessitates whole lot discussion. Who will be at the cost? Should I be doing? Should there be government incentive and the circle about subsidies, right? Second is about a lot of companies, especially the big ship liners, are getting into decarbonizing their whole fleet, or even on the procurement side, buying side, they are getting into 5 years, 10-year, long contract. And mind you, if you really talk about getting a shipment which is fleet or say merchant ships, just like airline, you will have to give an order which is like order book 24 to 36 months in advance, right? So how is it that we are going for making a conscious choice about, say, 30% of my fleet mix will be necessarily electrical vehicle based? That's something which companies have to do. And on the cost part of it, does it really give you commercial advantage? So for example, if I am sending, say, cement or sugar, or say even some electrical components, or say jewelry to some of the markets and exporting from India, will my choice of vehicle be valued by the customer, who is and by customers I mean the cross dockers, the people who are handling the port activities, and also people who are like resellers of my products? Will they really be valuing? And one of the ways to see that is the whole trend about our clients being very ruthless about their sustainability disclosures, right? If you really go even after this webinar, if you check some of the 5 companies you follow, especially the global companies, you will see a lot of companies have disclosed their 2025 plan. But surprise, only 18 to 19% of them are really on the path to decarbonize. And when I say path to decarbonize, pretty much the success is in scope 1, scope 2, which is your direct and indirect consumption, and the CO2 emission which comes by virtue of that. But there is very less focus on scope 3. And let me now dissect quickly into what does that mean for us. If you see this page, which pretty much takes an example of, suppose you're in the business of manufacturing. So what do? You start with taking raw material. If you are a refining company or petrochemical based company, you will of course take your NGL or take your some of the other alternatives on the feedstock side. Then you will have miles and miles of transportation, which ensures that material is entering your gate. Then there will be lines of processing which will use a lot of heat, lot of steam, lot of cracking, especially when you talk of chemicals. And then there will be, depending on the kind of products you sell, there will be some distribution points, distribution centers, warehouses if you are selling consumer products, and retailer points, and also the points of consumption, right? But that is not all. Beyond the point of consumption, now our clients are also worried about the points of disposal and points of getting it back to the ecosystem, which is where I think, Professor Seema, to your point, circularity comes into picture, right? And I think some of the indications were given earlier when Mr. Vashni talked about the ways to circularize, and he was talking more on the chemical lines, right? And if you see my screen here, on the scope 3 side, there are certain categories of emissions, which now, even if you are an India-based company or India-based corporate, you will have to start discovering this. And I'll tell you, last year, April, pretty much same time, we signed a contract with one of the largest petrochemical companies in North America. And we are now pretty much 11 months into the program, and we have only finished 13 out of 15 categories within scope 3. You can imagine how complex this is. I'll give an example. If you are in the business of producing polymers and special chemicals, then you can use the same gasoline or the same feedstock in 2 ways. A, the feedstock becomes your raw material, and therefore it has to be accounted differently in your books, which is your ERP and IT. Second is, you can use the same feedstock to really burn the fuel, and therefore the understanding about how much of this actually goes into direct production, how much of this is really helping me in burning my fuel or, say, for example, charging my certain cracking line, that recognition becomes important. And the reason I'm telling you all this is where the complexity comes. And this is where it starts demotivating companies to say, okay, we will not do any, classic data-driven exercise on finding out what are our real emissions. And so far, 80 to 85% of companies globally have been reliant still on letting their suppliers use their own emission factors. And if you really let your suppliers keep on giving you their own emission factors, it will be pretty much gut driven. And second, because suppliers will have different levels of motivation, there is a possibility that 30% of your suppliers, or if you're lucky, 40% of your suppliers will give this, but 60% it will be TBD, which makes your disclosure a bit tentative. And that's the reason why a lot of companies are going towards having a data-driven approach on giving this disclosure, right? So I just wanted to dig deeper into this. Of course, we can go on and on. Last 2 minutes, I'll focus on talking about some of the complexities, and I think you heard in the last 10 minutes or so about how is it that you would like to tackle complexity on the accounting side. So if, for example, if India decides to export some of the important, say, precious jewelry to Singapore, or starts to export, say, for example, pellets, which is a variant of iron ore, for example, will Singapore be levying you the carbon tax, and will you be really trying to compensate that with the company to which you are selling, right? Another example is Tata Steel, right? Purchasing a lot of iron ore from, say, Australia and China. Now, is Tata Steel incentivized to go for the least cost, least emission method of production because some of the suppliers are also going that route, right? So there is a lot of collaboration which comes into the picture here, right? Cost consideration, I think we did talk about, we did talk about that very, very briefly. I'll encourage you to go through ctf.org and understand what does it mean. By the way, India is one of the signatories. India has got, I think, 800 million out of 5 billion fund, which has been pledged, which makes sense for us. And I do expect that in the next budgets and budgets, which are 2027 and beyond, at least government of India will allocate some more as joint investment in this area, especially to develop the east part of India. And technology maturity, especially if you talk about perishable goods, some of the goods which have a very, set shelf life, or I think Professor Seema ma'am, you did talk about dangerous goods, especially goods which have tendency to effuse your methane, right? So how do you ensure that they are stored, appropriately, right? Lot of leakages happen because of that, right? And whether eventually the last point and most important thing, whether your customer is going to pay for it, right? So are our customers really demanding for those kind of green labors? And is green labels, and is there really a business case for that, right? So that pretty much summarizes some of the challenges which at least I foresee, having worked in this domain on the supply chain side. Some of these may have direct implications for us as a country as it evolves 2047 and beyond. A lot of chemical companies, a lot of mining companies, I see manufacturing companies have started taking baby steps, but a lot of challenges for them. With that, I will take a pause and perhaps give it back to you, Professor Hima ma'am.
Yeah, thank you, Mithilesh. It was quite insightful. Well, having said that, so we did mention that technology is one side. There is other side also attached, that is the financial landscape which is coming. So when it's time about supporting the financial, physical infrastructure which is associated, for example, which I just mentioned that about transmission, distribution, integration with the conventional energy systems, scheduling, planning, and all at a project management level, who are going to fund this project? What is which is happening in the financial landscape now to actually realize this dream? Reliability, intermittency issues, ROI is not coming in time. Maybe it's a risky affair. Financial institutions not confident enough to kind of fund these called as green projects, which Viksit Bharat is looking forward to. So what have you to say on this, Tejas? Could you just brainstorm on that? Yeah.
Sure.
So, and introduce Tejas. Yeah. Again, I'd like to introduce you for the sake of the audience while we know you. So Tejas, Vice President Investments. He's been associated with the investment industry for past 15 years, comprising private equity, investment banking, and project finance across infrastructure projects. His aggregate investment experience across the deals includes about $1 billion equity commitments. That is quite applaudable. Tejas has been with the NIF since 2019 and is currently VP Investments for the NIF Master Fund. For the audience, NIF Master Fund is India's largest infrastructure-focused fund that aims to participate in the robust growth potential of Indian infrastructure. The fund has multiple platforms associated: ports, logistics, airports, renewables coming in all the way, which hopefully we'll be deliberating on. In the current role, Tejas is responsible for coverage across the ports and logistics, airports, and renewable energy linked investments, end-to-end investments. That is what he's looking forward to. And prior to joining NIF, Tejas has also worked with HFDC and multiple other banks. Let me also tell you that we are proud kind of institute because he is an alum of IIM Mumbai, formerly NITI. He also holds a computer engineering degree from Mumbai University. Thank you, Tejas, for accepting the invite. Yes, let's hear from you now.
Thank you. Thank you very much, Professor Hema. Thank you very much, Distinguished Director and the entire IIM Mumbai team for this, for organizing this seminar. So, like you correctly mentioned, I think there have been a number of very relevant insights made throughout the discussions, both from Mr. Varshney and from Mr. Kumar. I'll just try to maybe, bring together all of the pieces and try to put across how an investor would think across of this landscape, right? What we have in the clean tech space. And I'll also tie it to the supply chain because since I look at our investments across ports, logistics, airports, renewables, it's something that I do look at on a daily basis. And these are all equity investments, so we actually own these platforms. So the first two criteria, right? The most important criteria are growth and scale. So today our fund is $2.34 billion. That is 3 times the next largest fund that was raised for India. Now, really, for any of the investments to make a difference in India, it has to have the underlying scale and the growth potential. And I'll give you one simple example why the growth of yesterday is going to be very different from the growth of tomorrow. So if you look at China today, right? China's residential availability of residential space per capita is now equal to Japan. Now, most people don't know this, but what that means is the historical drivers of China, the domestic drivers of, say, cement, steel, construction, are not going to work because you now have enough residential space created in that country for a population of 1 billion plus people to make it equal to that of Japan, which is a highly developed country, which passed its demographic dividend back in the 80s itself. Right. So firstly, growth is going to be very different. Now, if growth is going to be different, where is it going to come from? The reason why everyone looks at India is because most of the incremental energy demand is going to come from India over the next few decades, up to 2017. In fact, if you read the reports from IEA, from multiple other agencies, the single largest contributor to decarbonization efforts globally is going to be India. At the same time, the largest consumer is going to be India. In fact, we have, as a firm, I have myself also worked very closely with NTPC on multiple assignments for clean energy, integrating renewables with Mr. Soniji, with Mr. Mohit Bhargavji as well directly. And interestingly, there have been a lot of efforts. In fact, with the NREL platform that NTPC has set up, we worked very closely because we have a platform, INR Renewables, and our investments are also across renewable energy. What is interesting is that what we are going to face going forward is, in fact, the first time in the last couple of decades, right, you actually have now coal plants being announced. If you see the last 10 years, you never had new coal plants that were being announced across the country. Now, I believe NTPC itself has a pipeline of over 10 gigawatts of new coal to be built out. And this is not something that is going to deviate us from the path of 2070 net zero, right? Because all the energy pathways, in fact, IEA recently released the energy pathways report. In all energy scenarios, given the scale of energy demand in India and the growth that we have, all scenarios to net zero require us to add incremental coal. The challenge is that the renewables build out that we are doing today does not address the 3 fundamental issues, because the 3 fundamental issues that we have are energy reliability, affordability, and sustainability. All of the sources that we have address 2 of these axes, while the third is left open, right? So coal brilliantly addresses your reliability and also addresses your energy affordability to an extent as well. But it is not a sustainable source. Renewables, solar and wind, you will get sustainability and you will get affordability, but you don't get them throughout the entire day. So you don't get the reliability. And geopolitics has introduced another aspect, which is energy security, which is why you're seeing countries trying to enter into long-term arrangements. Now, in some ways, we will have this trilemma continuing for some time. And just to give a sense, right, so we consume 1,600 billion units in a year. NTPC produces 1/4 of those with 17% of the capacity installed. So we are going to be a country that has conventional energy for some time, but clean energy supply chains and how will they look like going forward? Right? It's not a simple solution of simply adding solar and wind, because what we've seen from a practitioner's perspective, and we have been, we have a market share of over 10% in all incremental bids of solar and wind that have been happening over the past few years. We are seeing on the ground challenges of how much you can stretch standalone solar and wind to just keep rolling them off the ground. So back in 2015, right, there was one Mr. Manoj Kohli who went from Airtel to SoftBank, SB Energy, he set it up. And he had said in 2015 that, the future of solar and wind is going to be when you integrate with storage. We're standing here almost 9 years from there, and really storage, we have really nothing to speak about. So what is going to happen now? If you look at supply chain, I would break that into two pieces, which is the materials and the logistics itself. So on the materials side, if you look at plain vanilla solar and wind, while we are setting up significant capacity, both in the manufacturing space of solar modules, already a lot of wind turbines are domestically produced. We are still dependent to a large extent, like in fact, Mr. Vashni and Mr. Mithilesh also said, to raw material that is sourced from overseas. Right. And I'll share some numbers with you to give an extent of the dependence that we have. And these impact our day-to-day investment decisions on a real-time basis. So polysilicon is something on a kilo, right? On a kilo, you get polysilicon somewhere between $7 a kilo. That price during 2021 shot up to $45 per kilo. Now, that number does not mean a lot, right? But now let me put that in perspective. At something like a $7 per kilo, it's your polysilicon contributes about 2 cents in your module per watt. When you move that to 45, that contribution goes up to 12 cents. And the typical cost of a module is somewhere around 20 to 21 cents per watt. If it goes above that, then you really don't have a base case for solar deployment in the country. So that's the extent of dependence that we have on raw materials from overseas. And China has taken more than 70 to 80% of the polysilicon production globally. And it's all concentrated in China currently. And that is not on account of raw materials. It is on account of subsidized electricity. So polysilicon, essentially the key raw material is heat, energy, electricity. China heavily subsidizes its electricity sectors, which is why you have most of the large polysilicon factories which are set up in China. And these are also, incidentally, funds talk about this, but they are set in regions called Xinjiang, which if you just search about it, is a politically affected region in China. So it is a very difficult sector to tackle. In fact, globally, one of the reasons why Indian industry has been helped in terms of manufacturing is because the US and the other countries banned modules from China for human rights violations in their polysilicon factories and production facilities. And that has been actually helping India. So when we actually generate domestic capacity, today capacity is not being put in India, it's actually exported overseas because you get much better prices in the US. And that's the truth. So no matter how much domestic capacity you set up, the fact is today I can't procure competitively from India, not because capacity is not available, but because everyone prefers to export it. It's a bit like saying, the best mangoes in India are exported since we are in that season. But that's true of materials and of the supply chain. The second piece is transmission itself. You briefly mentioned this, Hema ma'am. So, we have 420 gigawatts capacity installed. We have a transmission capacity of 1200 MVA. That's a ratio of 2.8. The global average is 7. So the point that we are trying to say is scale is in India is going to be extremely important for us to reach our ambitions. Like both, and transmission today is the single largest constraint in deploying additional wind capacity. Wind in India is somewhere close to 3.5 rupees per unit. If offshore wind is potentially a much more expensive solution. So we have in fact 4 gigawatts of offshore winds that have been bids that have been announced in Tamil Nadu, a gigawatt in Gujarat as well. But typically offshore wind costs about 12 crores per megawatt. Onshore wind is close to 6 crores per megawatt. And the economics speak for themselves, right? So in India, because you have onshore wind potential, that will always be the low hanging fruit before you try to deploy offshore. And today onshore wind sites, you will have to build a transmission line of 45 to 50 kilometers just to reach the substation because our transmission network is just not going out fast enough. So I'm mentioning each of the components in the supply chain because all of these, the transmission, the energy, the materials, will have knock-on effects on how the supply chain develops, right? For materials and for logistics both. Green hydrogen, Mr. Vashne mentioned a lot of relevant points. What was most relevant was that he mentioned the circular economy for hydrogen rather than simple electrolysis of water, which is what is put out so often in the out today, right? But the fact is that simple electrolysis from water is highly inefficient. So you put in 55 units of electricity to create a kilo of hydrogen. But when you use it as electricity, you can only get 33 units. So your efficiency is close to 69%. If you convert that to ammonia, you only get 21 units, so your efficiency goes down further to 39%. So what we struggle with as investors is essentially when you include some of these aspects, hydrogen is not competitive on a cost-to-cost basis vis-a-vis grey hydrogen. So the principle of decarbonization will not lead to investments being made in this sector. And that is what we're seeing on the ground today, right? So we have been making pilot projects in hydrogen. We've been waiting for large-scale projects to take off. Unless there is a mandatory supply obligation for green hydrogen, that is what will kickstart the industry. And that is what is being done in Europe to an extent. So in Europe, public sector buildings are mandated to use only green steel. That is to create the demand so that the demand can follow and the supply can be created based on the demand. The last piece I'll mention is logistics. And the only point I want to put out there is India today is going to be very different from a logistics space in the next 3 to 4 years. I think the infrastructure that we're building out, the dedicated freight corridors, in fact, Mr. Mithilesh mentioned the east and west, right? The dedicated freight corridors that we have now, immediately the western corridor and then the eastern corridor. That's an investment of over 1 lakh crores. And to give a sense, rail is 6 times lower in terms of carbon intensity vis-a-vis road. Now we might mention life cycle emissions, the entire DFC build out, but the fact is the DFC is already with us. So we have to look at as sunk emissions, and going forward, what is most efficient is the fact that we should use rail. And today through our ports platform, we have a 12% market share in both inland rail logistics for the domestic and the EXIM segment both. And one of the biggest selling points that we have is this fact that if you move your cargo through rail with us, you will actually be having 6 times lower emissions compared to road. In fact, there is a platform, there is a website, Cargos, which a lot of our customers use, and our partnership is with DP World. So a platform is set up with DP World. You can actually go to cargos.com and check the website. It gives an emissions calculator end to end. And that platform has been very useful for us to actually gain incremental business because it attracts customers. And the C&I piece that we mentioned, right, the emissions piece. So today our electricity, per unit of electricity generated, we are burning about 0.92 kilos of carbon. That's because we have such a high intensity of coal in our energy mix. This also makes it extremely attractive for someone like an Amazon or a Microsoft to decarbonize their India operations. Because if you go to Norway and you set up renewable energy, the fact is you're offsetting only about 0.2 to 0.3 kilos per unit generated of electricity. But you come to India, your offset is close to 0.9 because our grid is so dirty currently. So everyone, all the large corporations, when they come to India, they want to decarbonize because it shows up like an amazing decarbonization effort in their global efforts. So we are seeing that as traction on the ground from the commercial and industrial customers. In fact, we are signing a number of PPA contracts. In fact, of the railways itself, we are developing round-the-clock power projects where we are integrating battery along with solar and wind. And that battery is not going to be lithium-ion only. In fact, the lowest hanging fruit today is pumped hydro. By far, in terms of cycle efficiency, in terms of reliability, in terms of longevity, pumped hydro has been the solution that is the most economical and effective in terms of an investor return perspective, which is why you would have seen a number of investments being announced in this sector as well by multiple corporates. In fact, we were among the first companies to tie up for a pumped hydro solution. We are going to supply 300 megawatts of power to the railways. And over the next 3 years, whatever round-the-clock power comes to the railways, we have more than a 50% share of it. So it's a very different scenario than what we had, and not based simply on the materials like lithium ion, which are attractive from a individual efficiency perspective, because lithium ion is still the most attractive from a battery storage, but it does not work at scale. And really the larger scale is the grid. We might talk about EVs, we might talk about the business, but the scale is where the utility scale grid works at. So I'll just stop there, and the number of initiatives that the policy makers have taken in terms of the Gati Shakti terminals. In fact, the Gati Shakti scheme is not unique to India. In fact, policymakers in Europe, Germany, Malaysia, South Korea, all of these countries have national logistics plans, which are to an extent even overseen by the PMO's office. So the plan that we have developed in India is actually very relevant, and we are actually seeing the implementation of that on the ground. And the key takeaway will be the increasing share of rail. So today we are still 26%. That share has to go up to about 40 to 45%. That is imperative from a supply chain perspective and also from a decarbonization perspective. So I'll just stop there. I hope I've given a flavor of all the investment landscape, the considerations, and the financing to an extent. I mentioned the equity financing in my discussion. Bank financing essentially follows equity financing. So as long as the smart money is going after the correct investments, the banks essentially are very willing to lend to projects. Our platform today, just to give a sense, we have under construction projects. All of our projects are rated in the A category, even under construction. That's because when an investor makes a commercially viable financial decision, the banker sees it as well, and he's very happy to invest alongside the investor. So I'll just stop there. Happy to go into details of any of the points that I mentioned. Thank you so much. Thanks.
Okay, so Tejas, while you have given us a good snapshot of the entire supply chain related issues, given us the hiccups also, we need more solutions from you. We'll come back to you. But as of now, we are being joined by Honorable Director, Director IIM Mumbai, Professor Manoj Kumar Tiwari. So, sir, can I just introduce
Thank you.
for the interest of the audience, sir?
Yes.
Very brief. So, sir has asked for a brief intro. While that won't be possible, but I'll try my best. So, Professor. Director Sir, I would say. Director Sir has been the founding director of IIM Mumbai since August 2023. And he also has served as director of National Institute of Industrial Engineering, Mumbai from 2019 to 2023. He's also serving, he's on board as a Vice Chancellor of TIS, Tata Institute of Social Sciences, as an additional charge. If we talk about his research credentials, he's actively involved in research in domains like optimization, modeling, decision support systems, data mining and logistics, supply chain management, manufacturing. I think it covers all. He's associate and a very senior editor to very renowned global journals. Then he's also known, he's known globally in the academia and the research parlance. He's also serving, he has some more than 370 articles in leading international journals with H index of 85 and 30,000 plus Google Scholar citation. He's a fellow of very reputed National Academy of Sciences, NASI, Indian National Academy of Engineering, West Bengal Academy of Science and Technology, Academy of Sciences, Indian Institute of Industrial and Systems Engineers, US, and many more. He has also been recently awarded with a very reputed David F. Baker Distinguished Research Award. So this was a very crisp intro about us, sir. Over to you, sir.
Tejas?
Yes.
So first of all, let me extend my welcome to all the speakers, Mr. Rajan Vasneji, Kumar Mitles, and Tejas Devas, on this particular topic of clean tech driven supply chain management. In fact, idea of this clean tech issue recently came because there was a lot of focus that how we must behave in coming days, because there is a departure from the way of running the supply chain, and also our desire to protect the environment as well as bring something new, which is more abide by the mandate that we have signed with respect to carbon cap. And not only that, also we have to have something which is consuming less energy and promoting more, like recycling of the materials and, more land use in proper manner. So combined, if you include, then when I say clean technologies and application supply chain, then it took all the three components like environment, where idea is to promote circular resources. Then we have carbon positivity, then land use and water use. Because at present very less people are talking about water footprint. More people are talking about carbon footprint. But when we say Viksit Bharat at 2047, then at that time I think there will be much more talk also on the water footprint. Then comes economy. So certainly, as very nicely expressed by Tejas, and also we have seen Tejas recently during our discussion with the ministry officials, at BKC, where he was heading and, spearheading a very good campaign that how this clean tech things and financing aspects of the projects based on the, guided principles of the government, that how this can be solved. Viability gap funding is one thing where his organization is very nicely involved. So, Tejas, thank you very much for being part of such a, impressive projects which has larger impact on the nation. And then coming to the economy again, then fair businesses is how we can involve transparency and kind of, openness in doing the transactions, like application and adoption of technologies like blockchain, AI/ML, and all other, very clear decision-making tools. In society, everybody knows that if we follow the proper trend and have a more safe kind of things, then healthy community and empowered individuals, they will be the outcome. So keeping this in mind, that various courses and programs which are being taught now, say for example, how the AI/ML and distributed ledger, that is the blockchain, IoT devices in green procurement, blockchain in green procurement, and also many of the less energy guzzlers in the warehouse operations, that how we can have a more clean and sustainable warehouse operations, utilizing renewable sources, reduce energy consumption, and also some of the very interesting problems like how the routing decisions of the vehicles for ships, airplanes, find out the better optimized route, consolidating the materials in proper manner, and also like mixed use of the different energy fuels. Similarly, as you can see now on the road, you may find that there is charging station, there are fuel pumps. So now there will be hydrogen cylinder distribution centers also will be there, because many of the vehicles are coming up which are being run by the hydrogen fuels. So once that comes into picture, then there will be different scenario like how the renewable electricity generation getting using the electrolyzer, and then distribution of storage of the hydrogen. And in this context, what kind of changes that will take place in the feedstock, production, transportation, airport terminals and port terminals, and then how we have to design the refueling stations for the hydrogen. So keeping this in mind, we have to build up many of the robust design of the route planning using the hydrogen fuel, and particularly when there is a huge demand uncertainty. So such a challenging problem require like what will the feedstock cost, capital cost, operating cost, and these costs are also like forced by the production, storage, and refueling stations, and they have to observe several challenging constraints which are practical in nature, like installation and operation storage, and installation and operation of refueling stations, and also that how we can generate for such a large constraints a better and easier computing environment for solving such a complex and challenging problem. So in nutshell, I summarize that whatever our honorable speakers have talked about the different technologies, solar, hydrogen, and wind, also some of the mixture of both geotechnologies for harnessing the power through grid and also through the storage systems. They all need to be properly tried up in the initial phases, unless because of technology is growing day by day, we don't know that what will happen after 10 years. The Gartner trend and others, they are suggestions. But many of the labs and scientists, they are trying to have some breakthrough, which may be entirely changing the landscape of the energy generation and energy use. So if that comes, fine. Otherwise, as a scientist and as a technologist, we have to move the idea, advocate the idea of how the mix of the things can be used actually to reduce the burden on environment, to leverage the economy by way of green financing, and also to support the society by better living conditions and better healthy conditions. So with this note, certainly we all appreciate the quite what you call it, deep involved concerns that you have shown. And I started listening right from the Kumar Mithlesji was ending, and before that, Rajan Basneji mentioned some things of mine and Tejas, and hope that we will meet again sometime physically to deliver more on this, because we have got a mandate actually to develop the futuristic manpower requirements for Viksit Bharat in the logistics domain. Under that, one of the big challenges that because of these emerging technologies and its operation in the supply chain, at present we require 2.2, we are 2.2 crore people in this sector. But what will happen when you are following all these QR code, digital platforms, and multimodal parks, and then different kind of packaging tools, and the day-to-day problem of airport when air is not getting connected to the plane. So how long can we have this kind of what you call untrained and less skilled people work on these emerging tools? When the robots and other AGVs, they will be the part and parcel of the daily life actually. And those who are not able to see it, say many of us are using mobile, but the moment some problem goes, perhaps we have only option left to change the phone because hardly there is any proper mechanism. People are knowing that how it can be repaired. So therefore, in this changing environment, what kind of skill set we need, what kind of managerial acumen we need, what kind of supervisory level knowledge we need. So these need to be checked out, and perhaps in this context, I need your advice and suggestions also that how to prepare the policy for futuristic planning and education in the logistics and supply chain sector. With this note, once again from core of my heart, thanking you all for coming. And now I request Emma to have the further proceedings on this. Thank you very much. Sir.
Thank you, sir. So, team, I think that kind of integration of academia and industry is required right now, that the perspectives should meet and align and understand what problems are there and how we can fix them. So, sorry. Should we take one or two questions? Okay. So, team, I just wanted to understand if we are trying to just sum up the entire thing. While we understand that sustainability won't come cheap, cleaner solutions won't come cheap, and we have to tweak the business as usual scenario and align towards this clean tech solutions. And they just did mention that we have to come up with kind of financial funding, that support system. Financial institutions are gearing up to fund these kind of projects, while uncertainties do exist. But considering that India's energy mix is very coal centric, how are we going to get that price parity and the throughput, which the renewables with the clean solutions might not be able to provide? Also, add on that the intermittency problem is there, reliability problem is there, which the conventional solutions do not have. So, what is the solution right ahead with, from the team side now? How should India go about? How can we, level, take the situation forward?
Yeah, Himaji, let me give you the solution also. I had hinted briefly CSP with thermal storage. Whatever technologies I have discussed, they are all ready to be scaled up, but the demand has to be there. And some of them have already scaled up at say 1 or 2 locations and they are commercially available. So this concentrated solar power is one such technology. We do thermal storage during the sunny hours and use this electricity, use this heat to convert water to steam and run just like what we do through coal. Only boiler is replaced by a heat exchanger, which is having the heat stored in molten salt in one tube and outside the water is flowing and is making steam. And that steam turbine runs just like it is not intermittent. It is totally firm and dispatchable as per our requirement. We can meet the peak load, we can meet the night load, anything we can meet. And the technology is very much mature. Already more than 7,500 megawatt capacity is installed across 23 countries and more than 150 plants are running. But thing is, we have to address towards the solutions. Mr. Tejas described so much things, and let me add to that. We can have a firm and dispatchable grid system with the existing grid system itself. We may not need coal because we have huge high DNI areas. India is located so well geographically between tropics that we have run of Kutch, Thar Desert, Ladakh Desert, in South Karnool and this Anandpur and all. These are, and in UP, this is Bundelkhand. Lot many high DNI areas are lying idle. This land cannot be used for anything. And we can do concentrated solar power from here. We can just concentrate the heat of sun through mirrors, and from that receiver tube we can pass on our heat transfer fluid for which can be molten salt or anything, and store the heat during the day. We can put more mirrors to generate more electricity or more heat. Similarly, the grid part you said, or is in general this is there, that if I convert say 300 kilowatt hour heat to 100 kilowatt hour of electricity, I am wasting so much heat. And I am using that heat to produce again that electricity to produce heat again. My industrial process heat, say 80 degrees centigrade, 120 degrees centigrade, or even for steel plants and other things like EF and other things, electric arc furnace and all. So there is no use of wasting so much heat and efficiency. We can directly use the solar heat through CSP and other things, and raise the temperature, and at a very highly efficient manner. Similarly, there are more processes getting developed. Previously, pyrometallurgy you may not have heard, but now this branch is coming up which uses the heat to make bauxite to alumina, alumina to aluminium. Why you need electricity when you can do it through heat? And why you need that grid, and why you need that strengthening and all? Uh, Rather, this will, if you see, day by day, air conditioning load is increasing in India. Today also, about 40% of the energy requirement is heat and cooling only. So what we can do is, with existing sources itself, we can convert the heat from sun, use it directly, or through VAM, vapor absorption machines. We can do it through cooling also. We can have district cooling, district heating, or directly supplying to industry. And similarly, the same power can be supplied to industry wherever it is required. ISTS is free. Like if you do it in India, it can be 100% make in India, and it requires only glass, which is not requiring any drilling. You can just use the sand and make the glass. Similarly, molten salt is something which is NaNO3, KNO3, potassium nitrate, sodium nitrate. You can use it during the whole life of the project, which can be even 70, 80 years. More than 50 years plants are running, CSP plants are running. So glass doesn't corrode. It doesn't, it is more or less inert. So it will remain as glass for 100 years, and you try to see, you just have to, it is a super cold liquid. You just have to remelt it and you can make it in any form again. So today's investment of say 20 crore per megawatt or 15 crore per megawatt will give me enough returns, many times more returns. In a coal plant, salvage value is nearly zero. Here it will be maybe 4 to 5 times the initial cost which I am putting. You can imagine after 100 years what will be the price of fertilizers. NaNO3, KNO3 can be sold as fertilizers. Similarly, glass can be remelted. So, and moreover, that base load to peak load, which we were discussing, like more capacity to be added just for meeting the peak load. Today, the base load is say 100 gigawatt. Peak load is 243 gigawatt. And this includes that 30-40% energy requirement for the heating and cooling. So my peak load will tend towards converge towards base load, and base load will increase when I use that electricity for other jobs. So that extra capacity which I put for just meeting the peak load, which will be there for 1 hour or 1 second in a year, and is not getting utilized, that capex is going in anyway from the taxpayers only. Similarly, the transmission lines are going for PV. The
Yep.
CUF is hardly 17 to 20%. So if
And
we use everything and take a holistic view, we can have a very well made business case. This CSP plus thermal storage can give you at less than rupees 3, 24/7 renewable power. And it can reduce our grid carbon intensity tremendously. Similarly, we can have a cheaper heat. Why I will use biomass or gas or other things for heating or coal?
One,
When I
one,
do it directly. So if we see these angles, energy transition is not a costly business. Only thing is we have to have intermediate stage funding at a convenient procedure or at a convenient rate, which doesn't require that blending finance at say for 50 lakh or maybe 10 lakh. So
one
if
thing,
these
one thing which I wanted to add. Sorry, Mr. Rajan, to interrupt you. Maybe this will help you answer this better. Is from the industry standpoint, they care for low cost energy, but they also care for continuity of it. And especially if you talk about continuous processing, mining, for example, chemicals, I think you have taken so many examples. What we have seen is our clients are, especially our customers, are also worried about, does this give us continued 24/7, 365 kind of, does this assure us of the energy we are waiting for? I think that could be one key
Let me
consideration.
address this point. Your PV or wind don't give you continuous, but you are saying that it costs me only 3 rupees per unit, but it is not really 3 rupees per unit. You have reduced the transmission charge to nil, and you have been putting up coal-based plant which you don't run during the day. Your CUF of coal-based plant, which was previously 93%, has come down to 57%. So who is paying for this capacity? Similarly, transmission line capacity CUF is hardly 20%. For balance 80% of the time you are paying, but that has been cross-subsidized to different consumers. So what I mean is, it can give you 24/7. I am not dismantling my coal plants. Whenever I require during the rainy day or whatever, I can run the coal plant. Why are you worried about? You will get the 24/7 hybridized power. Maybe today the coal is 90%, tomorrow coal may be 10 or 20% if you average over the year. I'm
So,
not saying dismantle all the plants, decommission all the plants. Whatever
Amit,
you have, you do it with this and in a much more cost-effective manner. Today, my new coal-based capacity, capex is around 10 crore per megawatt. And when I use the levelized cost, it is around not levelized cost, initial cost. It is around 6 rupees per unit. Out of that, 3 to 4 rupees is coal only. And in my CSP case, which can give me 24/7 power with thermal storage, which is the cheapest storage over any horizon, maybe long term, short term, medium term. And battery is costing me 12 rupees.
coming in, Mr. Vashne. So I think, Mithilesh, you can have a consulting project from Mr. Vashne now. It's like the hats have to change because the industry, the power sector has a very different viewpoint. That's something very interesting, which is coming in from a consultant.
I will summarize that. In PV and wind, the real cost is around 12 rupees per unit if you have to have the 24/7 power. And here you can do it in 3 rupees. And it is not limited to CSP, I mean electricity. You can have the thermal storage instead of battery storage. And similarly, you can have heating and cooling, all much more cheaper. And when India gets cheaper electricity, cheaper power,
So, Mr.
your
Vashne, so you
all
say
the
that
things get
price parity is there, that the price parity is there. So maybe the investors are now keen to look forward to that. Yes, the price parity would certainly be coming in, and that risk proposition from the financial side won't be there. So this
Yeah.
is what required. Tejas, you want to add on to that? He's saying that,
Maybe I'll just add one point. Actually, Mr. Vashne made a very relevant point that today your transmission grid subsidizes your renewables because your transmission is going to be used only for 20% of the time. But the country that we live in, we are going to deploy incremental renewables. We are going to have incremental transmission capacity. Unless that fundamental equation changes, we will always have solar and wind deployed along with battery. Because if I were to give 85% power and I'm delivering that to the railways, I'm giving it at 4.1 rupees today. This is 85% annual PLF with 50% availability in any time block. If I were to do that with any other sources, it would be more expensive. All the simulations that we've done. And Mr. Vashne is right. That is because your grid today or ISTS is free up to 2026. After that, there are charges. Till then, all of us in the renewable space, we are enjoying the benefits of the free transmission grid that is provided to us. If that is taken away, then all renewable energy sources will become much more expensive. And perhaps that will be, that is the policy support that we are working on to deploy renewables, coupling with battery storage. And that's why we are able to reach a cost of somewhere between 5 rupees at which you can deliver firm power. So I'll just add that one context.
That was very relevant, but I just want to have one last word from you for how long government can, or for instance, in other kind of technologies, can keep on subsidizing, maybe a capital subsidy or some other kind of subsidized policies coming in. For how long we can continue getting those, and till what time we'll become some kind of self-reliant where the projects are on their own?
So this on the transmission side, this is likely to continue for the foreseeable future. And that is because if you see in the US, renewable energy deployment is much lower because of the fact that you have to incorporate the last mile transmission connectivity cost in your project cost, which is why renewables are much more expensive in the market like the US. Similarly, in other developed markets as well. So we are getting the benefits of cheaper transmission grids. But the fact is, it is helping accelerate our deployment, because without it, given the fact that you are comparing with coal power, which is average purchase price of close to 3.5, 4 rupees, we would never get the start itself for deployment that is required. Now we've got an annual deployment of 18 gigawatts. Now possibly the subsidies are being scaled back as well. So ISTS has a path from 27, 28 onwards. ISTS levies are going to be scaled back. So you will see that process coming in over the next few years.
Okay. Right, Tejas. So I see that there is a good synergy coming in while difference of opinions are there, but that is what the brainstorming sessions are all about. And finally, we have to sing together so as to make reality something called as clean tech solutions into our supply chain and into our systems. That kind of integration is required. With this, I think any question from the audience? So we'll formally close the session. We actually have now many pointers for, it's like food for thought now, addressing the technology, the supply side, the physical infrastructure which is required, who is going to fund that, who is going to support that, how the scaling up will happen, how the ROIs paybacks would be coming in, whether they'll be coming in or not, what would be the time factor which will go in, cost benefit analysis, etc. A lot to be done. That is an integration of stakeholders across the value chain now needs to happen so as to make clean tech into making for Viksit Bharat. So with this, I thank all the eminent panelists who joined us. Thanks Tejas, thanks Mithilesh, thanks Mr. Varshney. And now I would like to thank all the students who joined it, the faculty members who joined it. And last but not the least, the entire event was powered by Honorable Director Niti. I am Mumbai. I'm sorry, I'm Mumbai. And the chair for the Viksit Bharat team, I am Mumbai, that is Professor Seema Unikrishnan. We thank Madam for that. And the supporting element, supporting faculty, Professor Hema Date, Professor Purnima Sangle, Professor Sumi Jha, Professor Priyanka Verma, Professor Poonam Singh, Professor Devrata Das, Professor Jasashwi, Professor Vipin, Professor Ramesh, the IT support team led by Ms. Pratima, and many students and guests and the startups who have joined us today. Thank you so much for giving us enough pointers, enough barriers, enough solutions. But the diaspora will continue because this is just the starting on where the academia and the industry are coming together to talk about these topics. So we can say that we have actually started walking this talk, but we have we are just gearing up. So more needs to be done. More capacity building exercises need to come in play. So with this, I thank you all.
Thank you so much. Should we ask everybody to put on the video
Yes.
for a photograph? So even the audience, try to put on your video, please, so that we can take a pic.
Yeah, right.
Audience also, can we request you to put on your, yeah, I can see Professor Vidya has put on. Yes, yes. Can you all put on your audio and video? Sorry, not audio, video, please. Yeah.
We have, please hold on for
We
a minute.
have-
We are still getting.
Yeah.
Yes. So should there be any suggestions coming from your side, please post us to us on our LinkedIn or social media profiles. We look forward to hearing from you again. Thank you, panelists, for joining.
And thank you to all the audience, the faculty, the students, the defense officers. Thanks a lot.
Yes.
And a special thanks to all the esteemed panelists. Thank you so much.
Thank you. Thanks a lot.
Thank you, Brian.
Thank you. Thank you so much. Thank you, Mr. Vashman. Thank you so much.
You will fill it.